All right, good afternoon, guys. I just wanted to do a quick video on factoring trinomials, and this is when your a value is not 1. When your a value is 1, I think we've got a pretty good handle on that. That uses the other graphic organizer. Of course, you can use this one too. It still works the same way. But if you are trying to factor and your a value is not 1, it's something larger than 1, then we want to use this organizer. So we are going to factor out 5n squared plus 19n plus 12. Okay, so a couple of things we're going to check for first. First thing I want to check for is, does it have a greatest common factor? If I can divide all three of these numbers by the same thing, then it makes my problem a lot easier. So, does this have a greatest common factor? No. Okay, so that's step 1. Step 2, I want to multiply my, well, no, let me take that back. Step 2, let's determine our signs. This is where most people struggle, is we want to see, we need to figure out what our signs are. So, let's identify our A, B, and C first. So we have A is 5, B is 19, C is 12. So let's look. So let's look at our C value first. It's 12, and 12 is positive. So since my C value is positive, that means my signs are the same. If my C was negative, that would mean I would have two different signs. Okay? And so when I'm talking about my signs being the same or different, I'm not talking about, are these two signs the same? I'm talking about when I get my answer, when I get my two factors, are the symbols in between the two terms in the two factors, are those going to be the same or different? All right, so if C is positive, then I'll have the same signs. And then the sign of B is the sign of the larger number. So in this case, B is positive, which means my larger number is going to be positive. But again, since they are the same, that means not only is the larger one positive, but the smaller factor is positive too. So they're going to both be positive. Okay. All right, so the next thing, because we have an A value, we have to take into consideration. What we're going to do is we're going to multiply A and C. So A times C. Okay, so 5 times 12, and that is 60. So my end goal is I want things that multiply to give me 60. And I need factors that when they add, they give me my B value, which is 19. Okay. All right, so we need things that multiply to give me 60, but add to give me 19. So I'm going to just, and they're both positive. So I'm going to start listing positive factors of 60. So we have 1 and 60. 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Is that it? I don't think 8 goes into 60. Nope, it doesn't. All right, and 6 and 10. Those are all of our possible factors. So each of these pairs will multiply to give me 60. Now I need to add them to see what's going to give me 19. So 1 and 60 is 61. 2 and 30 is 32. 23. 4 and 15 is 19. 5 and 12 is 17. 6 and 10 is 16. So I'm going to use 4 and 15 because those add to give me 19. So we're going to use 4 and 15. Okay, so we have some good information to use, and now we're going to use our box. So we're going to fill this in. We put the first term in the first box. We put our last term in the last box. And remember, we said we wanted to add to 19, but really what we want to add to is 19n, not just straight up 19. We want 19n. So instead of just 4 and 15, we're going to put 4n and 15n in the box. Okay, so we have this filled out. So remember, if you're in my class, the way I've always explained this is that you are given the answer to a multiplication problem. Now figure out what I multiplied to get this. So if you remember when we multiplied in the box, you would multiply this and this to get this, and this to get this, and so on and so forth. So now we're trying to figure out what these have in common so that I know what I'm multiplying, which sounds kind of crazy. But what we're basically going to do is find the greatest common factor in each row in each column. So we'll start with our first row. So I want to find the greatest common factor between these two items. So what is something I can divide 5 and 4 by? I can't divide, nothing goes into them evenly except for the number 1. I'm also going to look at the number of n's I have. I have n squared and I have an n, so I can divide both of these by 1 n. So that's what I'm going to do. So my greatest common factor between these is just the n. Okay, so then I have 15n and 12. So what can I divide 15 and 12 both by? The greatest common factor is 3. That's the largest thing I can divide both of those by. And I can't factor out an n because there's an n here, but not here. So they don't share that, so I can't factor that out. Okay, so let's look here. What can I factor from both of these? So I can divide 5 and 15 both by 5. And then I can also divide out an n. They each have an n that I can divide from. And then let's look at this column. I have 4n and 12. Those 4 and 12 can both be divided by 4. And again, I can't take an n out because this has an n, but this doesn't. All right, so I'm almost done. I actually have my two factors right here. So remember, my signs were the same and they're both positive. So I should have a plus sign and a plus sign. So my two factors are 5n plus 4 times n plus 3. All right, so how do I double check that? Because that's a lot of work, and I would hate for you to do a lot of work and it not be right. So what we're going to do is we'll just multiply. We have 5n plus 4 times n plus 3, which it should, when I multiply, should give me this back. But let's just double check. So 5n times n is n squared. 4 times n is 4n. 5 times 3 is 15, and then carry the n. 3 times 4 is 12, and then when I add this, I should have, this should be 5n squared. Sorry, I didn't carry that 5. Should have 5n squared. Add those to get 19n, and then at the end I have 12. Which, to double check, this matches our problem. So again, we want to make sure we have the correct answer. This is not the answer. This is me checking. So let me write that. That's me checking. The actual answer is this. I have a lot of students who are like, well, don't we need to work it out from there? If you work it out from there, you get your problem back. So no, we're not working out. It's like you have the answer to a multiplication problem and you're trying to get the actual multiplication problem. Okay, so I kind of stepped that out, I would say kind of slowly. It did take me 9 minutes to do one problem, so I'm going to kind of go through some of these others a little more quickly since it's the same type of problem. So we have 15n squared minus 27n minus 6. Oh, can't see that. Okay, so the first thing we want to see is there a greatest common factor? Is there anything I can divide all three of these numbers by? And this time there is. I can divide all three of these by the number 3. That's my greatest common factor. So I'm going to factor out a 3, and if I do that, I'm going to divide all three terms by 3. So 15 divided by 3 is 5, so I have 5n squared minus 27 divided by 3 is 9, so 9n, and then 6 divided by 3 is 2. Okay, so I've factored out a 3. So because I'm factoring this and not this, I need to make sure that this 3 is carried down into my answer. So the very first thing I'm going to do, just so I don't forget, is I should have 2 binomials with a 3 on the outside. I'm just making sure I have that so that when I go to factor it, I don't forget this. Okay, so I factored out my GCF. Let's list our A, B, and C values. So A is 5, B is -9, and C is -2. So I'm actually going to factor this piece instead of this piece. We divided that 3 out, and look, what's going to be easier, to multiply 5 and -2 or to multiply 15 and -6? Make this easier on yourself. Don't make it more complicated than it has to be. All right, so let's determine the signs. C is negative. So since C is negative, that means that my signs are different. Okay? B is negative, so that means the larger number is negative. And if the larger is negative and they're different signs, that means the smaller number is positive. So when I start factoring, I'll make sure that my larger numbers are negative and that my smaller numbers are positive. Okay, so remember, we are trying to get things that, let's multiply our A and C so we can figure out what we're trying to get. So A times C, I'm going to do 5 times -2, that gives me -10. So I need things that multiply to give me -10, but add to give me -9. And again, my larger number should be negative and my smaller number should be positive. So we're going to list all the factors. So I have 1 and -10. I have 2 and -5. And those are all my factors of 10. So when I actually when I add them, 1 plus -10 is -9. 2 plus -5 is -3. So when I go to choose 2 factors to use, I'm going to use the ones that add to -9. So my 2 factors are 1 and -10. Okay, so I have all my info I need. Now I'm just going to fill in my box. So first term of the polynomial goes here, so 15n squared from here. Ooh, I lied. We're using this one, sorry. So we're going to do 5n squared. Sorry about that. So 5n squared, and then we're going to use -2. And then we're going to use 1x, or I'm sorry, n, because we're using n's here, not x's. So 1n and -10n. Sorry, I know that's super, super messy. I lost my train of thought. Okay, so we're going to divide. So let's go with this column, and it doesn't matter which order you go in, just make sure you've done each column and each row. So we'll do this top row. So 5n and n, the only thing that they share is an n, so I can factor out an n. -10n and -2, they both have a negative, and they can both be divided by 2. 5 and 10 can both be divided by 5, and they each share an n, so this is going to be 5n. And over here I have n and -2. And they don't have anything in common, so I'm just going to put a 1 there. Because if you don't have any factors or any greatest common factor, everything can be divided by 1. All right, so I have my factors. I have a 5n plus 1. And here I have an n minus 2. And that is my answer in factored form. So if I want to check this, again, I can multiply. I'm going to get 5n squared plus n minus 10n minus 2, and that's going to give me 5n squared minus 9n minus 2. And the other thing I want to check, remember we have this 3 out front, so we're going to multiply this by 3, and that's going to give me 15n squared minus 27n minus 6, which was the original problem that we were given. So we are, okay, this is correct. So there's my answer. Okay. All right, so I'm going to do 2 more examples. So yeah, let's just move on to it. Okay, so I'm going to go ahead and write them both down before I forget. So we have 4x squared minus 35x plus 49. And then here we're going to have a 6x squared plus 7x minus 49. Okay. All right, so first things first, is there a greatest common factor? And there is not for this one. So that's fun. So we're going to have a big number to multiply, but that's okay. So let's list our A, B, and C. Next thing we want to do is we want to check our signs. So C is positive, which means my signs are going to be the same. B is negative, which means the larger one's going to be negative. But since they're the same, that means the larger and the smaller are going to be negative. So they're both negative. So, yeah, both negative. Okay. So, next thing we want to do is multiply A times C. And so we're going to do 4 times 49. Okay, so I'm going to try to do this in my head real quick. You can use the calculator to check me. But I know that 4 times 50 is 200, and 200 minus 4 is 196. Woo! Alright, so my end goal is I need 2 negatives that multiply to give me positive 196, and when I add them, I get negative 35. Okay, so let me grab a calculator. So the good thing is, once you start doing this a lot, you can still list every single possible factor. I think it might be a good idea for a while just to get used to what your factors look like. But like, I know 1 and 196 are not going to add to negative 35. Let's see, what's 196 divided by 2? So we have 2 and 98. And remember, these are all negative. Negative 2, negative 98. That's not going to work either. Okay, can't divide by 3. We know that we can do negative 4 and negative 49. 5's not going to work. 6 isn't going to work. Let's try 7. I don't think it's... Ooh, negative 7 and negative 28, which I think that's what's going to end up working. I don't think... Yeah, it can't divide by 8. Can't divide by 9. Can't divide by 10. 96 divided by... I don't think divide by 12 works. 12, 13, 196 divided by 14. So, oh, 14 and 14. And then I think we're good. I think that's as many factors as I can get out of it. Okay, so I can add everything, but I can go ahead and tell you that negative 7 and negative 28 are going to add up to negative 35. So we're going to use negative 7 and negative 28. Okay. So then I'm going to fill in my box with my first term and my last term, and then my 2 factors that I came up with. So negative 7, negative 28. Okay, so we'll look at our first column. I can divide I can divide 4 and 28 both by 4, and they each share an x, so we have that. Okay, so sometimes it's kind of tricky to see when you should factor out a negative, and this is kind of done. Well, first off, let's remember that both of our signs should be negative, and that's why this is a positive number, is because we're multiplying 2 negatives to get a positive number. But just in general, if the negative is closer to where you're factoring, pull it out. That's so, like, that doesn't seem very scientific or very mathematical, but, and I'm sure there's probably an exception. Sorry, I'm getting emails on my phone too. So anyway, I'm sure there's an exception, but for right now, I think, remember that you should have 2 negatives here. But for right now, if it's on the outside, I think you should factor it out. So we're going to factor the negative. 49 and 7 can both be divided by 7. Okay? And then 4 and negative 7 don't have anything in common other than a 1, but the x's I can factor out an x. Here I can divide both of these by 7 again. So this one's negative, so it's closer to the box, so I'm just going to factor out that negative. All right, so I should have, I think that's it. I have 4x minus 7 and x minus 7. All right, and so my factored form should be 4x minus 7 times x minus 7. And again, you can check that. Oops, 7 times 4 is 28, that's fine. 7 times 7 is 49, which that gives the exact same thing here, so it should add to 4x squared minus 35x plus 49. Okay, which works out, so here's your answer. Okay, moving on to our last example. So we'll go ahead and there is no greatest common factor. There's nothing that goes into both 6 and 7. So our terms are 6, 7, and negative 49. First thing we're going to do is determine our signs. So C is negative. So since C is negative, that means my signs are different. One will be positive and one will be negative. And since B is positive, that means my larger factor will be positive, and my smaller factor will have to be negative. All right, so then I am going to multiply my A and my C. So let's see. So we have 6 times negative 49 is going to be negative 294. You'll notice that I don't bother to put negatives in my calculator just because I know whether or not it's going to be positive or negative. Like that's just part of knowing your math facts, knowing whether or not something's going to be positive or negative. I don't really need my calculator for that. Okay, so I need numbers that multiply to give me negative 294, but when I add them, I get 7. So just some things that we kind of know. We do need our factors to be relatively close. Like 1 and 294 are not going to add up to be 7. Like we should just know that. So just make sure that you're using good common sense when you when you do these. You can still list out every factor, but we should know that negative 1 and positive 294 are not going to add up to 7. Let's see. So what else? We got 294 divided by 2 is probably not going to, that's not going to be anywhere near close enough. 294 divided by 3 is 98. So we're getting closer. 294 divided by 4 doesn't work. 294 divided by 5 is not going to work. 294 divided by 6. It's negative 6 and 49. 294 divided by 7 is negative 7 and 42. Okay. 294 is not going to divide by 8. 4 divided by 9. Nope, not by 10. I don't think by 11. I don't think by 12. Okay, 14 and 21 though. So we also have negative 14 and 21. And then if I add these, remember these it has to get to 7. So I have to subtract and get to 7. If these are super far apart, it's not going to work. But if they're kind of close, like 21 minus 14, that would give me 7. So that's what I'm going to use. And there may be something else in between there. There may be some more factors, but I don't care because we found the ones we're looking for. So negative 14 and positive 21 are what I'm using. So then I'm going to fill in my box. We have 6x squared, negative 49, positive 21x, negative 14x. All right, so let's start factoring. So I can divide both of these by 2 and by x. I can divide both of these by 7. I don't think... Oh, I can divide both of those by 3 and an x. I can divide both of these by negative 7. So my factored form should be 3x minus 7 times 2x minus, or no, 2x plus 7. Okay. Sorry. I keep forgetting, like, I'm working and I'm not paying attention to what you can see. So here's my answer. Now, if you remember, we said our larger is positive and our smaller is negative. And it's kind of weird because these are both 7. So, but we have to think when we multiply this out, 3 times 21, or I'm sorry, 3 times 7 will give us positive 21. 2 times negative 7 will give us negative 14. The smaller number is still negative. All right, and so if you want to check, set up your box. 3x minus 7, 2x plus 7, 2 times 3 is 6x, squared. 2x times negative 7 is negative 14. 3x times 7 is 21. Let me not forget my x's. 7 and 7 is negative 49. And if I add those together, that does give me 6x squared plus 7x minus 49. Okay, I hope that this was super helpful. Or if maybe not super helpful, just a little helpful. So make sure that you are practicing this. Use your homework assignments. If you still need some practice, there's this lovely thing called Google, and you can Google worksheets on factoring all day, every day. In fact, that's how I got these problems. So your teacher's not the only one that can Google factoring worksheets. Y'all can too. All right, hope this was helpful. You guys have a great day. Keep practicing this, okay? Have a good one.